हरि करना।
Welcome to the second part of fifth module, that is everything about Maven. So here Maven is a build tool. So we are going to discuss about how to build a source code into an artifact. So everything about Maven and what all steps will be there in the building process. So we are going to see, as the title of this slide says, everything about Maven. That's what we are going to look. So first, let's understand what really is a build process. Maven is a build tool. So when you say Maven is a build tool, so what is that adjective build here? So what does it mean? So what really a build is? So let's begin to look into what is a build process. So a build process starts with a source code. What is source code then? Source code is the list of human readable instructions that a programmer writes, often in a word processing program, when he is developing a program. So source code and object code are the before and after states of a computer program that is compiled. So programming languages that compile their code include C, C++, Delphi, Swift, Fortran, Haskell, Pascal, and many others. So let's look into one of the example of Java source code. You can see that this is how it looks like. Example, you want to have a digit button text. So string digit button text. So if you give information like this 7, 8, 9, so you will get the digit button. Then if you want an operating button, so this is what. And if you want a memory button, so you mention this way. And string special button, so backspace cce. So this is how the Java source code looks like. This is called a source code. Similarly, you might have seen Python source code. If you have done engineering, you might have seen C source code. Okay, so once your source code is ready, so now you have to go for the compile process. So the source code is run through a compiler to turn it into machine code, also called object code, that a computer can understand and execute. Object code consists of primarily ones and zeros, so it isn't a human readable code. So a compiler is a software that converts the source code to the object code, source code to the machine code. In other words, we can say that it converts the high level language to machine language. Moreover, it is necessary to perform this step to make the program executable. So this is because the computer understands only binary language. So some compilers convert the high level language to an assembly language as an intermediate step, whereas some others convert it directly to machine code. So this process of converting source code into machine code is called compilation. So let's look into the compilation more detail as we go through this, as we move ahead in this module. So, but some of the example that we can see, the compilation, the compilers extensions are Java C is a compiler extension for Java. PYC .pyc is a compiler extension code for the Python, and ROSYLC and many more you can find out. So PYC, at least .pyc is the compiler you might have seen in your life. So then once the code is being compiled, so next we will go for the tests. So unit tests are conducted by developers and test the unit of code, a module or component. So basically they'll test the unit of whole code. Unit of whole code, what is the unit of whole code? It could be a module or some component, specific component. So it is a testing method by which individual units of source code are tested to determine if they are ready to use. So it helps to reduce the cost of bug fixes, since the bugs are identified during the early phases of the development life cycle. And integration testing is executed by testers and tests integration between software modules. It is a software testing technique where individual units of a program are combined and tested as a group. Test stubs and test drivers are used to assist in integration testing. Integration test is performed in two ways. So one is the bottom up method and second one is top down method. So unit testing test each part of the program and shows that the individual parts are correct, whereas integration testing combines different modules in the application and test as a group to see they are working fine. Unit testing starts with a module specification, while integration testing starts with the interface specification. Unit testing can be performed by any time. On the other hand, integration testing is performed after unit testing and before system testing. Unit testing is executed by the developer, whereas integration testing is performed by the testing team. So unit testing errors can be found easily, whereas in integration testing it's difficult to find errors. So unit testing is a kind of white box testing, whereas integration testing is a kind of black box testing. So the best examples for unit testing tools or unit testing or integration testing tools are PyTest for Python, heavily we used for the Python code, and Selenium. It's widely used for it's like multi-purpose tool, and Nose2 rational integration tester, protractor, and so on. So once the source code has been compiled and then tested, unit tested and integrated integration tested, so now it's time for package. So a software package is a collection of system resources that are packed together. So these packages enable the end user to perform some types of tasks when the software package gets deployed or moved across various servers and installed on their device. A software package could come in multiple formats. It could be .exe and MSI. So exe and MSI being the most common ones used by independent software vendors. Normally, in short, we say ISV, independent independent software vendors all over the world. And also jar, jar is widely used for Java based applications, and zip is for the general purpose applications. So once your source code has been compiled and tested for unit testing and then integration testing, now it's up, and once testing is done, then you'll go for the packaging. Once packaging also has been done, now it's time for health checkups. So can we ever imagine sitting back and manually reading each line of code to find flaws? To ease our work, several types of static analysis tools are available in the market. So, which helps to analyze the code during the development and detect fatal defects early in the software development life cycle phase. So, such defects can be eliminated before the code is actually pushed for functional quality assurance. A defect found later is always expensive to fix. So, most modern software intensive organizations deploy Code analysis tools in their development and quality assurance cycle. This is a relatively new phenomenon in the last several years as code bases have gotten more complex. So, quality assurance has become more sophisticated, and organizations have understood that testing is too expensive and insufficient to prevent errors from getting into live systems. So most code analysis tools in the market today are deployed by individual developers. So sometimes with the minimal management, so involvement, minimal management involvement. So some project managers and architects aggregate the results coming from code analysis tools into team level dashboards. So to put everything, to sum up in a nutshell, well, developers write the code. We call this a simply a source code here. So you can see that the first step of this complete flow. Okay, the first step, developers write the code. We call this simply source code. They are creating a product like a web application or a mobile app, anything that is a source code. So they keep committing the changes to the source code, and while they commit the change, they would like to test it. So they will compile the code, and this especially for the compiled languages like Java, .NET, C, like that. So they will compile it and compile the code, then they test it. So if it works as per their wish, then they will package it. So after the testing, if it works as per their wish, they will package it. So compile process is going to generate some files, the output files that they package it into an archive. The files that were generated from the compile process will be tested, and after that these files which were generated from the compile process will be packaged, and we call that as an archive. So a source code is generated or changed programming languages like Java or .NET. So then the compile process will compile it. So once the code has been compiled, if it's a Java code, then the compiler like Java C will be used. The extension after the compiling, the extension will become a dot Java. So when it is compiled, the Java C compiles it, then it's going to generate class files. There will be unit test or integration test, so that this unit test or the test written by the developers to test their own code. So this is, and you don't confuse with uh, this unit testing or integration testing with the software testing. That's a completely different process, and it happens in a different level. That also we are going to see, but this is completely a different activity that we are doing. This is not the software testing. So a unit of code will be tested by a unit test. That's it. A small module of code, a piece of code will be tested by a unit test. So if that works fine, then the class files will be packaged. So now based on what the target is, like if it is a software for Windows machine, then there will be a .exe or .msi format of packaging or archiving. So .exe, .msi, these are the archives methods of extension. .jar, .var is for Java. So if a Java web application mostly packages in war format, or other languages like Python, Ruby, other interpreted language will be simply archived into zip format or a tarball. So then also, if there is the step done by the developer of health check, that will be performed by the developer. So health check or code analysis. Health check is nothing but a code analysis. So this process is going to find any upcoming bugs or security vulnerabilities. Two things are very important. One is upcoming bugs, one is bugs, and second one is vulnerability. What is vulnerability? I'll tell you. In our we have some specific modules for this bugs and modules. There we are going to discuss in the code. So in short, this is the entire build process. Now there is a lot of steps. So developers, along with the writing their code, regularly committing their code, they also need to regularly do this build process, which is too much work if they have to do it very regularly. So in short, this entire build process consists of a lot of steps. So developers, along with writing their code, so regularly committing their code, they also need to regularly do this build process, which is too much work if they have to do it very irregularly. So to automate this process, to automate this entire build process, we need some tools. So here we are going to discuss about those tools. So there are build tools built to simply automate the build process. The best example and the widely used example for this is Maven. So which is for Java. It's Maven is basically for Java, and it's based on XML format. So as I mentioned in the XML file, so we have to mention in the XML file what you want to do, what are the dependencies, and what is the versioning mechanism. All those things you have to mention inside the XML file, and you have to run some Maven commands, and Maven tool is going to execute your build phases automatically. But whatever activities that you have to do, you have to mention in the XML file as the orders or commands. So then it will execute all these steps, and it will automate your entire build process, and the entire build process will be automated using a Maven tool, which takes a XML format file. And you don't need to run them manually. Like we have one more tool for Java, that is ant is also again for Java. So but there is more scripting involved in ant, and in generally Maven. So that's the reason in general Maven supersedes Ant. So then we also have more tools. That's MS Build, which is the Microsoft build engine. If you are writing code for the Microsoft product, you will be using a build tool like MS Build. And there is one more tool, that's a Gradle. Gradle uses a different kind of scripting format. That's a Groovy format. We use the Groovy format similar to the Jenkins, that we are going to see Groovy format in Jenkins also. Next part of this module is Jenkins only. So we will be looking a Groovy format there also again one more time. Okay. So then Gradle is Groovy format. Then we have Nant. Nant again, this is for Windows, or so, which is executable programming program like our RPM, Debian packages, or any program that's executed on the operating system. So there is make, there is one more tool, there is a make. So make build tool that can build from code to the program. So and there are many, you can see that there is a make tool. So make also builds executable programs and libraries from source code. So and there are many build tools based on your target, based on the programming language. The right build tool will be decided, so the developers or the software architects will already decide what is the build tool, and they will set the build process rightly. So to sum up which tool to be used, the decision will be made based on your target, based on your target programming language, and on which platform you are doing things. If it is Windows, then you will go for the MS Build or Nant or Make. If it is Java, obviously you have to go for Maven or Ant. So if you're going for Java, then you will have to decide Maven or Ant. In that case, I would go for the Maven because of less scripting, whereas Ant is complicated scripting, and I won't go for the Gradle because it's DSL based on Groovy. It's a bit complicated scripting. So it's all, we have to decide on certain factors. But it makes your life easy by automating your build process. I always prefer Maven for Java, so that's the reason, with some additional benefits, some positive points that Maven carries. Because of these positive points, I would like to go with the Maven. So in this tutorial, in this course, we are gonna deal with Maven only. So that's the reason. Now the question arises, what is Maven? So Maven is a Yiddish word meaning accumulator of knowledge. Began as an attempt to simplify the build process in the Jakarta turbine project. There were several projects, each with their own Ant build files that were slightly different. So jars were checked into CVS, and they wanted a standard way to build the projects, a clear definition of what the project consisted of, an easy way to publish project information, and a way to share jars across several projects. The result is a tool that can now be used for building and managing any Java based project. And the result is a tool that I and likes of me, the ML ops or DevOps engineers who love and adore a tool, Java based, to work on Java based projects. That is our Maven. So, and they have created something that will make the day to day work of Java developers and DevOps guys and ML ops easier, and generally help with the comprehension of any Java based project. So now the question arises, okay, they have built a Maven tool, but what are the objectives of the Maven tool? So Maven's objectives. Maven's primary goal is to allow a developer to comprehend the complete state of a development effort in the shortest period of time. In order to attain this goal, Maven deals with several areas of concern. So, first one, how to make the build process easy and providing a uniform build system and providing quality project information and providing and encouraging better development practices. So making the build process easy. So while using Maven doesn't eliminate the need to know about the underlying mechanism. That's the main objective of Maven. So you should not spend more time of learning and knowing the underlying mechanism of how to do that. And so Maven does shield developers from many details. And the second objective is providing a uniform build system. What does it mean? So Maven builds a project using its project object model. We call it, in short, we say POM. POM. So Maven builds a project using its project object model and a set of plugins. Once you familiarize yourself with the Maven project, you know how all Maven projects build. So this saves time when navigating many projects. And the third objective is providing quality project information. So when Maven provides useful project information that is in part taken from your POM, again project object model, and in part generated from your project sources. For example, Maven can provide a change log created directly from source control, and Maven can also provide cross-referenced sources. Maven can also provide mailing lists managed by the project and dependencies used by the project depend and unit test reports including coverage. So third-party code analysis products also provide Maven plugins that add their reports to the standard information given by Maven. So now let's look into the fourth objective, that's encouraging better development practices. It's as simple as that. It's encouraging. So while you using Maven, so the Maven makes you uh, to Maven encourages you to uh, practice better development practices. So it's like providing how will it be done. So it will be done through providing guidelines, a specific guidelines for best practices of development. So Maven aims to gather current principles for best practices development and make it easy to guide a project in that direction. For example, specification, execution, and reporting of unit tests are part of the normal build cycle using Maven. So current unit testing best practices were used as a guidelines. So keeping test source code in a separate but parallel source tree and using test case naming conventions to locate and execute tests. So these are the guidelines which are provided by the Maven for the to make you practice make you follow the best practices of development. And having test cases set up their environment instead of customizing the build for test preparation. And Maven also assists in project workflow such as release and issue management. Maven also suggests some guidelines on how to lay out your project's directory structure. So once you learn the layout, you can easily navigate other projects that use Maven. So while Maven takes an opinionated approach to project layout. Some projects may not fit with this structure for historical reasons. So while Maven is designed to be flexible to the needs of different projects, it cannot cater to every situation without compromising its objectives. So if your project has an unusual build structure that cannot be reorganized, you may have to forego some features of the use of Maven altogether. So now we have seen what is Maven. We have seen what are the objectives to come up with Maven, and now we will also see what is not Maven. What is not Maven? So Maven is a site and documentation tool. If you think that is only a site and documentation tool, no, it's not that. Maven is a tool which does more than that. Maven extends and to let you download dependencies. No, not at all. Maven is not made for that purpose. Maven purpose to automate the build process and to provide a best practices and to provide a uniform build system and to provide a quality project information. So that's what the purpose of Maven. And Maven is a set of reusable Ant scriptlets. No, not at all. A big no. Maven is completely a tool altogether. It's a different tool altogether. What is Maven and what is not Maven and what are their objectives? Now let's look into how Maven works. How Maven works. So before we look into the flow of Maven work, so first let's understand the terminology that was built around Maven. So the core concepts of Maven. So the first important terminology, the term that you should know is POM file. POM, project object model file. So what are the form files that you can see on the screen? A POM file. This is how it looks. So these are the components generally a POM file consists of. So POM files, project object model files, POM files are XML file that contains information related to project and configuration information such as dependencies, the first one, source directory, plugin goals, plugins. Here you see plugins, what are plugins to be brought and installed so that whatever the orders, whatever commands that you have written inside your script can be executed. Then life cycle phases, goals, and build profiles. So this all will be used by Maven to build the project. So when you should execute a Maven command, you give a Maven a POM files to execute the commands. Maven basically reads this form.xml file to accomplish its configuration and operations. So now inside the pom.xml file itself, we have seen some terminology, that's dependency. So what does a dependency mean? What does a dependency mean? From where will we get these dependencies? So dependencies are external Java libraries required for the project and repositories. So where this dependencies will be located, where will be stored. So repositories are directories of these packaged jar files. So basically all these dependencies will be packaged in jar files and stored in repositories. So the local repository is just a directory on your machine hard drive. So we have seen, so every time we used to say repository, remote repository, local repository. So when we say local repository, the local repository is just a directory on your machine hard drive. So if the dependencies are not found in the local Maven repository, so Maven downloads them from a central Maven repository and puts them in your local repository. So then we will see few more terms in this. Build life cycles, phases and goals. You see that? Life cycle, phases, goals. We'll see what are they mean. So a build life cycle consists of a sequence of build phases, and each build phase consists of a sequence of goals. So Maven command is the name of a build life cycle phase or goal. If a life cycle is requested, executed by giving Maven command, so all build phases in that life cycle are executed also. So if a build phase is requested, executed, all build phases before it in the defined sequence are also executed too. So then we'll see what is a plugin. So build plugins are used to perform specific goal. You can add a plugin to the POM file, that's form.xml file. Maven has some standard plugins you can use, and you can also implement your own Java plugin. Okay, so this is what your POM file and the terminology that's built around that POM X file or pom.xml file. We know what is Maven, and we also know what is Maven repository. So now let's look into the whole ecosystem once, how this Maven works as a tool. So first, as I have told you, you have to write your POM file. So there you have to mention what dependencies you have to bring up here, and then what all plugins to be downloaded, and life cycle phases, life cycles, and then phases, what all phases it should follow, and goals, what to be executed. And once your pom.xml file is written, you just save that file, and then our Maven comes into the picture. So Maven brings this form.xml file, a read form.xml file, then downloads dependencies that are mentioned inside the form.xml file into local repository from central or a remote repository. For all these dependencies, there will be one repository that's maintained. Inside that repository, all these dependencies will be stored. So when you this Maven, the second activity will be done by this Maven is to download those dependencies which are defined inside the pom.xml file into our local repository. So then the next step will be done by the Maven is to execute life cycles. See, you have mentioned phases, you have mentioned goals, you have mentioned, and plugins, etc. defines, it specifies the build path. So that's what Maven reads the pom.xml file, and then once it read through the pom.xml file, and it execute whatever is mentioned in that pom.xml file. So then once all done, it's gonna build a repository. So after that, Maven build it will build a repository. In that repository, you're gonna find out your artifact. That's what the final step of Maven repository. If you want to put in a nutshell, read pom.xml file and download all the dependencies and then store it in your local repository. Then execute lifecycle phases, goals, and build profiles and plugins. Once all done, you create a Maven repository, and inside that, you store your artifact. So as we have mentioned in the pom.xml file, you see that life cycles. So now we are going to look into the life cycles in depth. So Maven is basically a build lifecycle oriented and clearly says that these steps are well defined to get the desired output after the successful execution of the build lifecycle. So Maven is based around the central concept of build lifecycle. So what this means, what does this mean is that process for building and distributing a particular artifact, basically a project, is clearly defined, or the person building a project should be at least clearly defined. So this means that it is only necessary to learn a small set of commands to build any Maven project, and the POM will ensure they get the results that they desired. So Maven comes with three built-in build life cycles, so that you can see on the screen. So default, one build life cycle, clean, another life cycle, site, another life cycle. So let's begin with a default, then we will move to clean and then site. So what does a default build life cycle will do? A default build life cycle, so this handles the complete deployment of the project. So what happens inside that default, you see here, you begin with the validate. It begins with the validate. It validates the source code, then it compiles the source code. It will uh, convert the source code, the JavaScript, which is written in human readable format, into machine language. Basically, you say bytes, bytes, bits and bytes. You say bytes, not bit, bytes. Okay. So then this will be converted into, then once it's compiled, then it will go for the testing. So here it's unit test and integration test. So here we'll say unit test, then packaged, and after the packaged, integration test, and then we will verify the same and install and finally deploy. Sorry. So this is the complete deployment of a Java project. So that's how a default build lifecycle look like. Then we will look into a clean life cycle, a clean build life cycle. So this, what does a clean build life cycle do? So this build life cycle involves cleaning the project, as the name says, cleaning the project. So for what you need to clean, for a fresh build and deployment, if you want to create a fresh build and if you want to deploy it, so for that purpose you require a cleaning. So for that we'll use a clean build lifecycle. So it consists of a pre-clean, then pre-clean is done, then we go for the clean, and then finally we do the post-clean. It's the complete cleanup of our Maven repository. Then the last build lifecycle that we have here is site. So site, so this handles the generating the Java documentation of the project. It's mainly to generate a Java documentation. So pre-site, and it starts with the site. There you write something, creates a Java documentation. Then it will do the post site after the site, and after the post site, it will deploy the documentation into that. So that's the final one. It's called site deploy. So each of these build life cycles is defined by a different list of build phases, wherein a build phase represents a stage. Phase is equal to stage in the life cycle. So for example, let's take the default build life cycle, a default life cycle which comprises the following phases that you can see on the screen. For a complete, you can see the complete list of life cycles. Of course, whatever life cycle that we have seen here, they are just three, but if you want to explore, still you can get the complete list of life cycles, but these are not the complete list. Okay, there are a few more, but we will be discussing only three which are very important for us. Anyway, the default build life cycle begins with a validate phase. Either you can call it as a step or stage or phase. We would say phase. Okay. So the better terminology is phase. What is validate phase? Validate validate is the first phase for our default build life cycle. So a validate, it validates the project. The validate the project is correct and all necessary information is available. That's what the validate does. It validates the project whether it is correct and all the necessary information is available. So once the validation is done, then it goes to the compile. So it compiles the source code of the project and it will convert that into the byte code. Then once it's converted into the byte code, so then it will go for the testing, the test. So the test, then it tests the compiled source code using a suitable unit testing framework. You have to use an external third party tool here. So that's the reason you have to use a plugin. You have to write that plugin inside your pom.xml. So these tests should not require the code be packaged or deployed. So then we'll go for the once test is done, now it's time to package your compiled source code. So package, it takes the compiled code and packages it in its distributable format. It's normally a jar format, JAR. So once package is done, so now it's time to uh, cross verify the things. Okay, so few normally this integration test, few will do that earlier, but that's fine. All okay. So then we'll go for the verify. So what's verify? Verify run any checks on the results of integration tests to ensure quality criteria are met. So then we will go for install phase. So install the package into the local repository. That's what we call it as install. And once it is installed into the local repository, once the package has been installed into the local repository for use as a dependency in your project locally. So then the final step for us is to, once install is done, then the final step for us is to deploy. So deploy done in the build environment. So it copies the final packages to the remote repository for sharing with developers and projects. So this is what the deploy is. Deploy doesn't mean the deployment that we do, like deploying an application or deploy. No. So here what happens when we say deploy phase, here whatever the package that has been built during this default build life cycle, that package has to be put into some other server. It is not meant for this server, because this server is called a build server, but this package should be put in some other server, maybe for testing or staging environment, or for the quality assurance, or for the some other activity. So you have to do that. So you have to take this. Once it is built, then from here you have to deploy it into the some other server. So this is called deploy here. So these life cycle phases are executed sequentially to complete the default life cycle. Given the life cycle phases above, this means that when the default life cycle is used, Maven will first validate the project here. Validate the project, then will try to compile this will try to compile the sources or source code, then run those against the tests, run those compiled code against the tests, and then package the binaries, then package the binary code. Basically it was converted into the binary language, so package that into binary .jar code, then run integration test one more time and against this package, that package, and verify the integration tests, and install this verified package to the local repository, then deploy this install package from local repository into the remote repository. So that's it. From validating the source code, then compiling the source code, then testing the source code against some tests, and then packaging it, and then doing integration test and verifying the integration test efficiency and effectiveness, then finally install it in your local machine. Means you just put it in your any local repository, and then finally from here you keep that installed package in your local repository and put it into the some other repository for different purpose. Could be a testing, could be a staging, could be a quality assurance, and this is called a deploy, and this is called a complete build life cycle of default. And these are the different phases in that default build life cycle. So then we have one more life cycle to be seen, that is clean. So build life cycle of clean phase. So this clean phase is used to clean up the project and make it ready for the fresh compile and deployment. So the command used for uh, this purpose, this life cycle is uh, mvn clean. So if we say mvn post clean, so then it will be cleaned after the default build life cycle has been executed. So when this command is invoked, Maven execute the tasks via executing the commands like Maven pre-clean, Maven clean, and then Maven post-clean. So this means Maven, when you execute this, the Maven clean, so it first execute pre-clean command, then it executes clean command, then finally it executes Maven post clean command. So this Maven's clean is a goal, and on executing it cleans up the output directory, basically target folder, by deleting all of the compiled files. So note, whenever a Maven command for any life cycle is invoked, Maven executes the phases till and up to the invoked phase. Example, when we say mvn clean is invoked, when mvn clean is invoked, Maven will execute only the phase clean, but no compile or deployment site phase is invoked, because this is just Maven clean. If you want to invoke compile, deployment, and site phases also, then you have to use some other commands. So then let's look into the site life cycle also one more time. For that, I am taking back you to the previous slide because I did not put it here. Yeah, here it is. Here is our site life cycle. So apart from cleaning, compiling the source code, building a deployable format of the application, Maven has phase which does more than these phases. This is one of the vital feature provided by Maven which generates the detailed documentation of any Java project. That's very important. The documentation is very important. So this project documentation has dedicated phases which involves a pre-site and site, then post site, then finally site deploy. So the command used in Maven to generate Java docs for a given project is mvn space site. Basically, when this command is invoked, Maven calls doxia document generation, the docs, basically documentation generation and other report generating plugins. So here, so there are a lot of plugins. So doxia is one and doc is one. So it will call that plugin, so which can be used for the documentation generation. So doxia is basically a framework used for content generation by Maven. So this generates contents both in static and dynamic way. So this is how the life cycles default clean site works. So now let's look into what is XML format, because that's what the heart of this tool. Without that script, it cannot do anything. That's how it communicates with your hardware. That's how it makes all things possible. So that's why we will look into the XML first. So what is XML? So let's meet Mr. XML. So XML stands for extensible markup language. So you might have heard this kind of word, HTML, hypertext markup language, XML, extensible markup language, because both marks up your screen. It prints something, it marks what HTML does on your screen, it marks the things. That's how you are able to see the whole things, like whatever you see on your screen. That's called markup language. So XML is a markup language. It's much like HTML. It's much like HTML, but it's not same like or likes of HTML. So XML was designed to store and transport data. That's the main purpose of XML. That's the reason it's still alive and it was brought up for that purpose only. XML was just designed to store and transport data, to store and transport data. So XML was also, it's designed to be self descriptive. It changes with, so whatever you want you can put it. Let's see that what it is exactly. What does it mean, what does that self descriptive mean? Let's see. And XML is a W3C recommendation. So worldwide, that www, so that there they have that one conference, so that federation will recommend how that XML should look like. Okay, so now let's see what is not XML. So what XML does not do. So XML, maybe it's it's a little hard to understand, but XML do not do anything other than transport, storing and transporting data. So let's take one example. So first let's see that. So you see that this note which is on the right side of my screen. So that note is just a note to tow from Jenny, and it's stored as XML. There is nothing much. There is no further, not much of information. It's not going to do anything. Anything means anything. It's not, it does not do anything. It will just store that as a data and transfers that or transports that data to somebody else through some other medium. You require a medium to transport that. It's just storing and transporting data. It won't do anything more than that. So in this example, this if you see this example, it's quite self-descriptive. So it has a sender information, that's Jenny, and it has a receiver information, that is Toe, and it has a heading, that's a reminder, and it has a body, that's don't forget me this weekend. Let's catch up. So let's write this XML file exactly same way. Let me go to this directory, and I've taken created. Let me open this VS Code here. Let me make it smaller. Yeah. So click on the file explorer, close the get started, and go to the file explorer and open the file. So I'll write note.xml. You see that? You got the icon symbol. So now let me click on that. There is nothing specific here. What I have to write is I will write my I'll open the tag with note tag. So this is a note tag. So this is our note tag. You can see that note opening tag and note closing tag has been opened. So now let me take some space in between so that I can add the information. This is a note tag. So here we will have information about note. So the first is 2. So there are 2. So as I want to make it as a note, so I will add an indentation to this. Okay, so here I am going to add all the my message information, all the information here. So now to whom I'm writing, to Daksha or Dakshayani. So to that I'm writing, and what I'm writing, from whom, it's from Surya Charan Teja Rama. Okay, from me I'm writing. Let me give spaces in between, and here let me close the explorer now. It's not required anymore. Charan, yeah, from me, and I have to add surname also. That's fine. So from me to Dakshayani, and heading tag opening and closing. It's letter. It's love message. So body, what I want to convey. So now I'm writing body tag. You see that body tag got open. Don't forget to respond. Don't forget to think about my proposal. Okay, so this is what is our note consists of. You see that? So the same thing I can simply write it, say to Dakshayani from and heading or subject love says and body. So same thing. I can write it like this also. You can store this and write it similar way. So there is nothing much difference between this and this other than the format. So here you see that this is called an XML format. For everything you create your own note, own tag. So these are all your customized tags, and this is a normal way of sending the same message. So the XML consists of, it has a sender information, receiver information, heading and message body. So but still XML above does not do anything. Yes, it does something, but it does not do anything that you are expecting. It won't do, it does not do the things that you are expecting, because you might be comparing this with HTML and you are expecting to do the same thing. No, a big no. So XML is just information wrapped inside the tags, nothing much. XML is just the information. Here you see this example, it's the information which is wrapped inside the tags. So someone must write a piece of software to send, receive, store or display it. So this is the example. So this is a note, and then to whom, to from, to this girl, from this guy, and it is a heading is a reminder, and don't forget me this weekend. But don't expect that uh, this the heading means it will take it for a certain purpose, and heading means it will increase the size and it will give the boldness to that line. No, it's just a simple message which is wrapped inside the tags. It's just information which is wrapped inside the tags. So then what is the difference between XML and HTML? So XML and HTML were designed with different goals. XML was designed to carry data with focus on what the data is, whereas HTML was designed to display the data with focus on how data looks. XML tags are not predefined like HTML tags are. This is very important differentiation between XML and HTML in writing script perspective. For developer, so the very important differentiation is XML tags are not predefined like HTML tags are. So let's check how does it, how can we prove this. So here what I'm going to do is we'll go to the Explorer and we'll create one more file. So this time we say note.html. Okay, we'll copy the same thing, but how we're gonna write. So let me take this default HTML. So these tags, so each tag is predefined. When you use a doc type and mention HTML, this is doc type tag, doc type HTML tag. So it says it's a HTML document, and after that you start your coding. And the next tag we have lang tag. So here it talks about the script, the page that you're writing should be in English, and it should be printed in English. It should be shown in English, and you have head. So this head tag, opening and closing tag, if you wrap some information inside this head head tag, open and close head tags. So this information is basically about metadata. What's your website, what's your file name, and what are the viewport size, and what is the title of your document, and all that information, and which for which browser it's compatible, and all that information can be added. Then we have body tags. So here where you have to add your HTML code, which can be shown to your clients, shown to your users. So now let me copy that here. Sorry, I'll copy this one, node.html, because this is also similar. It looks similar, but there is a huge difference. Yeah, I have added this also. Now for note, instead of note, I would use an article. Okay, article. I'll give some space in between. Yeah, now I would use article. So the name I'm gonna write for article is note. No, for that also we will give heading h1 tag and note. Then after that, to whom, Dakshani. So I would use a simple h4 for this, and to, and again h4, rest all, from. Then we have heading. So this time I'll use h2. This is love message. Then finally we have body, but here we are going to give a paragraph. Okay, and we will write, don't forget. So let me save this and let me get back. Yeah, see, similar message. This is XML from here to here. This is XML and this is HTML. Let's execute this and let us see what how what could be the difference between both. How does it look like? How does XML look, and how does an HTML look? XML. Okay, so let me go live. It's gonna open browser. So it was open. If you see the first part, okay, I will add here. Okay, from this part you can see that in body, from this part to this part, it is from this part to this part, it is XML. So let me add heading 1. Okay, so that heading 1 XML, and same thing I'll do it for here also. This is HTML. So now let's go back let's dispose it and go live again. Now you see that this is XML was simply printed whatever is there on the screen. So because those are not predefined tags, where if you see HTML note is little bigger and it's bold, and these two dark shiny, these are also bold with something, and love message is H2, it's much bigger than all other. And don't forget to think about my proposal. It's as usual, it's a normal simple paragraph. So this is how you can make out the difference between HTML and XML. So you can write anything. In spite of notes, you can write a letter. In spite of a letter, you can write love quote or love message or love snippet or whatever you want. You can write, because these are not predefined. These are customized to your message. This is only to store and transport your messages or information, whereas HTML is to print that message on the screen. So HTML takes care of how it looks and XML takes care of how it can be transported. So that's the difference between an HTML and an XML. So XML does not use predefined tags. So the XML language has no predefined tags, as we have shown in our example. The tags in the example that we shown. So like to here in XML, to tag, from tag are not defined in any XML standard. So these tags are invented by author of the XML document. So now I have written this document. So I'm just the whichever is comfortable for me or whichever looks close to my information, that kind of tags I'm gonna use. I'm gonna write my own tags. So HTML works with defined tags like we have seen paragraph, H1, P, H1, table, etc. So with XML, the author must define both the tags and the document structure also. So XML is extensible. Most XML applications will work as expected even if new data is added or removed. So imagine an application designed to display the original version of node.xml. That's a two tag, from tag, heading tag, body tag. Then imagine a newer version of node.xml with added date, har elements and removed heading. So there won't be much difference. So XML simplifies things. So what XML will do? XML simplifies data sharing. XML simplifies data transport. XML simplifies platform changes. XML simplifies data availability. This is what an XML do. What HTML will do? HTML prints your data. HTML markups your screen. HTML makes sure your your source code looks on top of the screen, looks beautiful on top of the screen, not completely beautiful, at least it will make your source code to look on the screen, print on the screen, appear on the screen. So many computer systems contain data in incompatible formats. So exchanging data between incompatible systems or upgraded systems is a time consuming task for web developers. So large amounts of data must be converted and incompatible data is often lost. So XML stores data in plain text format. So this provides a software and hardware independent way of storing, transporting and sharing data. So XML also makes it easier to expand or upgrade to new operating systems, new applications or new browsers without losing data. So with XML, Data can be available to all kinds of reading machines like people, computers, voice machines, news feeds, etc., etc., and the list goes on like this course. Now it's time to see about POM, POM, a project object model, or POM is the fundamental unit of work in Maven. So it is an XML file that contains information about the project and configuration details used by Maven to build the project. So it contains a default values for most projects. Examples for this is the build directory, which is target, the source directory, which is src / main java. So the test directory, which is src / test / java, and so on. So when executing a task or goal, so Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. So some of the configuration that can be specified in the POM are the project dependencies, the plugins of goals that can be executed, the build profiles, and so on. So other information such as the project version, description, developers, mailing lists, and such can also be specified. So then what is super POM? The super POM is Maven's default POM, Maven's default uh, project object model. So all project object models extend the super POM unless explicitly set, meaning the configuration specified in the super POM is inherited by the POMs you created for your projects. So what is a minimal POM? The minimum requirement for a POM or the project root model version. So it should be set to 4.4.0. It's our latest one. Then group ID, the ID of the project's group. Then artifact ID, the ID of the artifact or project, and version, the version of the artifact under the specified group. So then let's look into one example, so which is written in XML file that you can see on the screen. So the main tag is project tag. Inside that, all other tags has been mentioned as we were discussing just earlier. So model version, that's 4.4.0, group ID, so you can give com.com, com.mycompany.app, and artifact ID, that's my app, and version 1. So that's how it looks. So a POM requires that its group ID, artifact ID, the version be configured. So these three values from the project's fully qualified artifact name. So this is in the form of group ID, artifact ID, version. So as for the example above, its fully qualified artifact name would be, from this example, check from this example, what's group ID? It starts with the group ID. So group ID is com.mycompany.app, and after that it will take artifact ID. What's the artifact ID? So its artifact ID is my app, and then version it will take. So com.mycompany.app, and artifact ID my app, colon, then after that colon again and 1. So this could be what, the name. You can see that here, com.mycompany.app colon my app 1. So this is 1, this is a group ID, then my app is artifact ID, then version is 1. All are separated by colon. These are colon separated name. So also, as mentioned in the first, around first and second slide of this part, it's if it is not specified in the POM, then the default value jar would be used. So furthermore, so you can see that in the minimal POM, the repositories were not specified. If you build your project using the minimal POM, so it would inherit the repositories configuration in the super POM. So therefore, when Maven sees the dependencies in the minimal POM, it would know that these dependencies will be downloaded from Maven repository, so which can be specified in the super POM. So before we look into some other concepts, let us look into the actual form that we use to build an application. So let me open a VS Code, and from File Explorer, let me open this in another folder. So I'll click on this, and I'll select this folder, and you could see that Maven symbol here. So let me make it bigger. You can see that Maven symbol form.xml. I'm gonna click on this and minimize. Yeah. So let me begin. So this is some standard, initially the project standard, so that it will bring all the standards from here. And here you see model version. As I was saying, let me minimize this, and let me, no. Okay. So now you can see that you just compare the codes one side by side. So model version, of course here there's a spring version. Here you see that model version tag, that's 4.0.4. Then you have group ID, that's a com.visual path. It, I would say, in spite of that, whatever you want you put. I have Charan, sorry, I say Imlai Charan. So that's what an artifact ID is, vProfile, or I would say then packaging war version v2 is fine, and name that you are expecting, I would say Imlai, yeah, vProfile web app, and rest all you can keep it. So this is the live example, the actual example that you can see. So that's what the initial information. Then after that you have added your properties. So MySQL connector dot version. These are all information about various dependencies versions. Basically, these are versions of different dependencies that we're going to use. So let's begin with the security, then JPA version validator and MySQL connector with 5.1.36, and then DBCP database one, then JSTL, JUnit version for testing, and logback version Maven compiler source is 1.8. This is what called the properties. Then you have dependencies. What all dependencies you want to use? Spring framework, a Spring framework, and Hibernate, MySQL. You see MySQL, common DBCP, Javax, JUnit, Mockito, Spring Framework, Javax. So a lot of properties are mentioned here. I hope you got some understanding about how and pom.xml looks like. So now let's look into the most important concept in pom.xml. That's project inheritance. Project inheritance. Elements in the pom that are merged are the following. So basically there are different elements of the pom that I have shown you. Begins with dependencies, developers and contributors, plugin lists including reports, plugins, plugin executions and matching IDs, plugin configuration, resources, and the super form is one example of project inheritance. However, you can also introduce your own parent forms by specifying the parent element in the form. So now let's see this example. So for the project inheritance, so if we take the same example, let's reuse our previous artifact. So this is the one, minimal POM. So what is that artifact? com.mycompany.app colon myapp colon 1, and let us introduce another artifact saying com.mycompany.app, and then here instead of my app I would say my module, and then as usual version I'll put 1. So and you can, by and large, you're using the same thing with the slight modification. So that's what it can inherit it. It can inherit the format. It can inherit the existing tags of minimal POM. So here you can see project tag is the main tag, and inside that you have subtags: model, version, group ID, artifact ID, and version. So now let us specify their directory structure as the following. So it should be placed in such a way that if you have a my module, and inside that you should have a pom.xml if you want to inherit it. So or else this, the pom.xml is the main one. This is the main form file, that's a pom.xml. Then the my module pom.xml is inheriting from this, so that's the reason it's looking like this. It's this my module pom.xml has inherited all the properties and all the tags of minimal POM that we have written initially. So that's why it's inherited module. It's an inherited module, it's not the actual one.